Hello, everyone, and welcome. My name is Steve Cash. We're going to wait just a couple of minutes here as the number of attendees just keeps ticking up, which is a good sign. We'll get started at about 2 minutes after. Thanks. Hello, everyone, and thank you for joining us today. My name is Steve Cash, and I'll be your host for today's webinar. Today's webinar is Unleashing the Power of Model-Based V&V, how your systems model becomes a roadmap to your verification activities. Given the number of participants that we see here, we should have a great dialogue and discussion in our Q&A session at the end. With us today, we have an exceptional subject matter expert who many of you may recognize, Andy Henderson. Before we meet our presenter, there are a couple of housekeeping items that I need to cover. First, we are recording this webinar for your reference later. Second, you will see control panels on the sides, typically on the right-hand side of the screen. You are muted by default, but we encourage you to ask questions. The chat window is read-only, so please submit your questions in the question window, and we will answer them during the Q&A session or as a follow-up after the webinar. Lastly, we will ask 3 poll questions during the webinar, and we will share the results so you can see how others responded. Watch for the pop-up window when it's time for the poll question. Today we are joined by Andy Henderson. Andy Henderson is a principal systems engineer and product manager for Genesis at Zuken. He spent 19 years as a systems architect for Northrop Grumman prior to joining Zuken. During his tenure at Northrop Grumman, he performed systems, test and evaluation, and reliability and maintainability engineering on a range of programs, from the NASA Orion Lunar Orbiter to small UAV programs and the Global Hawk family of UAVs, before moving into the Vehicle Management Systems group. Welcome, Andy. Thank you for being here today. Let's go ahead and get started with a look at the agenda and our first poll question. So the agenda for today will go through verification requirements and general background, model-based verification planning, using the descriptive architecture model to guide your verification activities, identifying gaps in your verification efforts, and using model-based methods to generate exports and share the results, create products, and connect data. Let's go on to our first poll question comes up. So the question for you is, how involved with verification test planning are you? Interested, but not practicing? You're a systems engineer or requirements author, verification or test planner, test conductor or tester, test reviewer or QA. We've got about 50% have voted at this point, so we're moving pretty good. We'll leave it open for maybe another 20 or 30 seconds, so please get your votes in. All right, it looks like our voting has slowed a little bit here, so let's go ahead and end the poll and share the results. Okay. Oops. So let's see if I can pull that back up real quick. Thank you. So looks like about 36% of you are interested but not practicing, and about 53% of you are systems engineers or requirements authors. And then we've got 6% as verification test planners, 1% as test conductor, and about 4% as the test reviewer QA. What do you think of those results, Andy? Any insights there to our audience?
Yeah, very interesting. And thank you for the introduction, Steve. But yeah, this poll result seems about like I expected. Again, a lot of systems engineers, a lot of requirements authors, which is great. The focus of this presentation is mostly to systems engineers as well as verification engineers, right? Test planners. And I'm glad to see we've got one test conductor or tester out there. That's awesome. So this is great. I'm hoping everybody gets something out of this presentation and finds it interesting.
All right. Let's get on to your presentation then.
All right, so I'll take it over here. And let's see, let's move on into the presentation. So can't really have a presentation on verification if we don't talk about verification requirements first. So that's going to be the first section here is what is a verification requirement and why do you need them? So what are verification requirements? Simply put, right, there's statements of the verification approach for each requirement. Every requirement should have the verification aspects of it stated. Okay. What does this help you do? Right? It helps you demonstrate that the requirement itself is verifiable. So many times I've written a requirement that I thought was good. It gets through to my testers. They look at it and say, well, I can't see this value or I can't measure this. The whole requirement's not verifiable as you've written it. Causes me to go back and rewrite my requirement. So very important thing to do, right? So verification requirements help to define the verification program, right? That's going to prove that your product meets your customer requirements, right? You need to prove that you meet those requirements. Really, I'm going to say this a few times because it's such an important concept, right? Verification requirements are the coordination point between engineering or systems engineering and the test team, right? Just like requirements are the coordination point between engineering and the customer, this gives me as a systems engineer the ability to coordinate well with my test team. And we'll get into how we do that here in the presentation. All right. Each verification requirement should address the following in this very convenient mnemonic, right? OMES. What is the objective of the verification? What is the method, right? What are the environmental conditions that it's going to be verified in, right? I mean, verifying something in a nice air-conditioned lab is quite a bit different than out in the field, right? So we want to state those conditions at every level. Are there any special conditions, right? Do I need any special setup, or does the system need to be in any special state to test? And probably the most important here is what is the success criteria for the verification requirement? What does it mean to have a successful verification? Is there a certain value that I have to get to? Is there a certain condition I need to be at, right? Those need to be very clearly stated. And again, it's really easy to remember these when you think of this mnemonic, OMES, right? It kind of sticks in the mind. All right, I do want to make a note here that, per in Genesis, per, our system design language, we split up the verification requirement from the requirement, right? So they're two different entities that are related. You don't always have to do that. A lot of organizations put the verification aspects into the requirement and whatever tool they're using directly. That is okay, right? So they can be combined and into a single entity. That's perfectly fine. If you do that, though, if you combine them and your organization starts having multiple verifications for any one requirement, it can get a little tricky to manage because now everything's all in one bit of data, right? And that makes it harder to split out, harder to manage. So I do want to point that out here, that none of these methods and things I'm going to be talking about have to include a verification requirement. Those aspects could be included in the requirement itself. It's really all about the verification aspects of the requirement. All right, let's start off with a few examples of verification requirements. So here, this is a verification requirement for a sample, little quadcopter drone project we like to use. So in this one, it says the requirement or the verification requirement is verify video drone system total production cost. So the statement was written as a cost analysis shall be performed on the total video drone system production cost to determine the production cost allocation that meets the allocated production cost for the system, right? The analysis will be successful when the rolled up cost to produce the drone system is less than or equal to the allocated production cost. So I've highlighted the kind of key segments, and let's break that down, right? The objective in green, right? Determining that production cost allocation meets the production cost for the system, right? That's the objective. The method clearly stated, an analysis, right? A cost analysis. Environment. Well, in this case, there's nothing highlighted as environment because we're doing an analysis. So that's not really done in an environment, so we can leave that out. That is okay. And then, again, most importantly, the success criteria in blue there, right? That it'll be successful when the rolled up cost for all the parts, right, is less than or equal to the production cost. Pretty straightforward. No special conditions here. Okay, let's do one more example as well. All right, so in this case, it's verifying the initialization of the drone. The drone shall test initialization within the objective initialization time. The test shall be performed in the operating environment and shall be successful when the initialization time has been shown to be less than or equal to the objective initialization time of 2 seconds. So doing the same thing, breaking that up, right? What's my O part of the OMS, the objective? Initialization within the objective initialization time, right? I mean, it's just a restatement of that requirement from a verification standpoint. Method, test, right? Environment, in this case, I did mention the operating environment. Now, note, I said operating environment, that should be defined clearly in my test procedure or test plan, what exactly that operating environment is. And then the success criteria, right? That it has to initialize within that objective initialization time of 2 seconds. So I'm dealing with a particular value, definitely tells me I'm testing. I'm starting something, I'm doing something, I'm measuring the time, I'm taking data, I'm dealing with a test. All right, so I do like to start off with that. Now, each of those sections in the OMS can be broken up and put into their own attributes if you want, or they can all be written into the verification statement paragraph like I've done here. That's a choice you can make. All right, and again, no special conditions here. All right, so let's talk about verification method a little bit more. So I would say verification method is, the most commonly set verification attribute, right? And it's so often set incorrectly. There is this abundance of just setting everything to test, right? I'm just going to test it, right? I wrote my requirement. It's early on in the program. I'll worry about, really how we're going to do this later. So for now, I'm just saying it's test. And that happens so often, and that sticks, which is not a good thing to do. We want to break that habit. The typical 4 verification methods that most people are probably most common with, or most commonly understand at least, analysis, inspection, demonstration, and test. There are some others. Sometimes you'll see examination instead of inspection. There are cases where your organization can break up those methods into sub-methods. I've been on programs before where we had, type 1 test, type 2 test, type 6 test. One was like ground, one was flight test, one was lab test, right? That can happen as well. So you can break these up, but these are the most common 4 as defined in the NCOSE handbook, as I make a note there. So what is analysis, right? Well, that's analytical evidence using calculation. And the important part here is that it does not involve the system of interest, really only models of the system of interest. Inspection, right? Visual or measuring, examination of the element to make sure it fits into a certain volume, something like that. That's usually inspection. Demonstration, right? Showing correct operation. And the key part here is without taking measurements, right? Very common. A lot of times people will write up a verification requirement and make the method test. And then when they write what it's actually doing, they're really just talking about demonstration. They're saying something like, if the aircraft, we want to, raise and lower the landing gear. And that's it. Well, that's a demonstration. If I make that a test, right, if I'm starting to measure how much force is applied or strain gauges, things like that, now we're talking test. But just doing something and seeing it getting done, we're dealing with a demonstration. All right, and test, right, like I said, exercising the system of interest while gathering measurable data. So if I'm putting my landing gear up and down and I'm measuring strain and stress and all those different things, and I'm gathering data that then I can check against the required values, I'm doing a test. So keep in mind, test is the most expensive form of verification, right? We ought to try to minimize its use. That being said, we don't want to under-minimize it. We need to test what needs to be tested, but not everything is test, right? Test has a huge trail of, support and engineering behind it and time, right? Test is a lot more expensive than just demonstrating, or even inspection's even cheaper than demonstrating, and analysis is usually one of the cheapest options you can do to verify a requirement. Of course, test is usually the most comprehensive. So again, be careful of its use, and it is often overused, especially by systems engineers early on in the program. All right, once that method is selected, right, finishing writing that VR, right, hitting those points in that OMS mnemonic, right, the objective, the method, the environment, the success criteria, can really help to confirm the validity of that chosen method, right? When I start writing the success criteria, and all of a sudden I find that I'm not really writing that I need to measure something, but I marked that as a test, that's a sign right there that I need to stop and go back and change that verification method to demonstration, right? That helps you as a systems engineer write a better requirement. All right, so why spend time on verification requirements? This is a question I get asked a lot, right? Most engineers will or systems engineers will write the requirement and they'll tack verification method to it and call it good. So again, trying to bring home why we want to do this. Again, coordination point between engineering and test, right? Again, requirements, the coordination point between customer and engineering, so we can have that flow from customer through systems engineering all the way to test, right? A requirement really is not complete without the definition of its verification. How do you know it's even verifiable? And again, so many times I've written a good requirement, given it to my testers, and they've come back with saying this isn't verifiable, which has caused me to go back and rewrite the verification and rewrite the requirement itself, that is. All right. Writing verification requirements will improve the quality of your requirements tremendously. Okay. So previous experience here, writing verification requirements on previous programs. On one particular program, we went through and we took all the verification requirements that were written, which were very thin. They were mostly just verification methods identified. We went through and wrote verification requirements for everything that didn't have one. We went through and we found just a tremendous error rate in what the initial requirement author had tagged it as a verification, for the method. Again, an overabundance of test, right? We went through and for just looking at the lab test procedures, we removed 13 weeks of testing. That wasn't really testing anything because it was mostly demonstrations, or it could have been done by analysis, or it could have been done by examination, right? And all this had been already factored into the schedule, and we managed to remove that back out. That's just huge savings. I mean, that's the kind of things that makes program managers just happy. It's the kind of things that win you awards for a company because it's just a huge time savings. So on that program, it was 13 weeks out of lab testing. We did the same analysis in the flight test. We removed 2 months of flight testing that was just not needed. So it was just absolutely huge. And every time I've done this, every time I've gone through and really looked at the verification requirements and gone through this trouble of writing them, we've just found so many errors and so many things we could improve, that we just really improved the whole verification effort. Yeah. When you're doing this, of course, always look for less expensive forms of verification. Not everything is test. Getting verification right is so important, right? Because any mistake you make here is so costly to catch later. Because really, this is about getting your requirements right. This is part of that effort. So you want to catch things early. You want to do a good job here. I do have a link in here to another presentation that this is from Steve Sukanik, who I worked for years at Northrop Grumman. He, taught me how to do verification and test. We worked together in this model-based environment, and this presentation is absolutely excellent. Goes into a lot more detail on verification requirements and examples and planning. So highly recommend taking a look at that. And a lot of this is based on that methodology. All right, so again, why bother with verification requirements? What's the typical flow, right? The systems engineer writes a requirement. The systems engineer pats himself on the back for writing a wonderful requirement that hits every style point in the NCOSI style guide or their own company style guide, right? They've done a great job. So what do they do next? Generally, they realize they should probably fill in at least the verification method. So early on in the program, sure, it's got to be tested. Yeah, test, right? Or maybe they don't even bother and they say, well, we'll fill this in later, and so it stays blank, right? In the end, that can result in incomplete requirements. We've all seen that. We've all seen requirements get to test, not testable. They're incomplete. They don't make any sense, right? This process helps to weed that out, right? Again, the systems engineer tends to spend little time thinking about verification when they should be the first line in thinking of verification when they write the requirement. It should be part of that thought process. So what happens when your organization forces writing a verification requirement, or at least the verification requirement attributes and things we've been talking about, right? There's required for that requirement to be complete to pass through a readiness review board or however your process works, right? What happens in that case? Well, we get this flow, right? System engineer writes the requirement. The systems engineer checks the style guide, pats themselves on the back. They wrote a great requirement. They didn't write anything dumb in their requirement. They didn't say the system shall support something, right? Which is my pet peeve. I can't stand those requirements. They wrote a good requirement, right? They get down into that verification aspect and they write that verification requirement, right? And they cover that objective, the method, environment, success criteria, any special conditions. When they do that, they're going to find out if the requirement was really well written, right? Because it will be verifiable. So if it is, great. They can exit the loop, right? And they go and they get an end result of a pretty good requirement generally. But if not, right, there's a feedback loop in this case where because that verification statement pointed out deficiencies in the requirement, they're going to go back and reevaluate that original requirement statement, loop back around, and adjust the verification until they get it right. And this is a case where you really would want to include your testers as well. Because again, so many times they've told me that what I'm asking for, they just can't deliver. And as a systems engineer, I may not have known that, right? So very important. And again, this results in that requirement author, producing a correct requirement, a better requirement, and hopefully having that kind of aha moment of why I'm writing verification requirements and why they are so important to this process. All right. So that finishes our verification requirement section and takes us to our next poll question. So I will turn this over to Steve again for our next poll question.
So the question for you is, does your organization require verification requirements? And your options are yes, complete and independent verification requirements. No, verification is built into the requirement attributes. Not only verification, no, only verification method is required. You're unsure or not applicable. We've got about 30% of you voted in already, and it's continuing to tick up. So we'll
By the way, I can see the results on my screen.
Okay, you can see him?
I can see him, yeah.
Oh, great.
Give everybody a few minutes, or a minute here.
All right, looks like we've slowed. Give it another 10 seconds or so. Any last stragglers want to vote? All right, let's go ahead and end the poll.
Okay. Wow.
What
I'm
do you
kind of surprised. Um, I'm surprised as many voted that yes, complete independent verification requirements are necessary, as many as that said it's built into the requirement. So that's a good thing. Because if it's built into the requirement or if it's independent, that's okay. I kind of treat both of those categories as the same. So that's a little over 50% do, which is excellent. That's actually really good. But we can still see there's a chunk out there, 21% at least, that still don't require these aspects. So hopefully, at least this presentation made it clear why it's such a good idea to spend the time to write the verification requirement. So good results. Thank you.
Yeah.
All right, let's continue on. So our next section here is what is a verification plan, right? And how do we do that in a model-based way? All right, so verification plans and procedures, right? Those are the sets of activities or the steps of activities that need to be performed, right, to gather the evidence to show the compliance with the verification requirements, right? It's the way what we're going to do to get the information to verify our requirements, right? So they consist of verification activities, right? And it's really a hierarchy of verification activities. So let's take a look at that hierarchy, right? At the top level, I call it a test campaign. It's what I've always heard it called, but it could be called something else. It could just be called overall test, or maybe your test campaign level for an aircraft is ground test and flight test, right? Very much depends what you want to call that highest level. But there is a top level, right? There is this top overarching set of tests that you're going to do to meet some major objective, right? That test campaign would break down, right? It's decomposed by test plans, right? So in this case, we have test plan A, B, C, right? Each of those decomposes another step into test cases. Again, this is usually the way that these break down. Sometimes you might go straight into, you have individual test cases, or maybe some test cases are used by different procedures. You can organize this however you need to, but this is a typical flow down. The test cases, of course, are going to contain individual test steps, and this is where we're starting to get into sequenced steps of the test. Okay. Again, it's very much a hierarchy, right? And keeping this hierarchy straight is very important. Okay. So again, verification requirements are really the why we're doing these things. Verification activities are what we're doing to gather in the information for the verification requirements. All right, so decomposing that verification activity, right? So we're at our test plan or procedure level, right? We decompose that into individual test cases, right? And then those test cases decomposed into individual test steps, right? Where we can flow it out. In these flows, we can apply behavior constructs as well. Typically, a test flow at this test step level is going to be very serial. You're going to do step 1, step 2, step 3. That's very typical. But you can apply behavioral constructs to this as well. I can put a parallel construct and say, test step 3 and 4 and 5 all have to be done before I can move on, right? That would be how I'd use a parallel structure. Or I can put in decision nodes, right? I can put in the fact that what happens if the test fails? Do I need to switch into some other test step at that point, or do I just record it, right? I can put decisions into the flow as well. And the more of that I can put in here, right, and visually lay out, the more of that you're going to capture, right? The better your test plans are going to be. I can also use constructs like iterates, right? I can iterate over a set of a test. In this example, right, we're talking about initializing our drone. Well, our drone probably uses a phone application, right, to control the drone and to program it and things. Well, I'm going to have to test for different phone operating systems. So I have to do the same test steps, but I have to apply that to different operating systems. So I can use an iterate construct to graphically show that here. Okay. Another important part too is when you're building these models, right, clearly marking each verification activity with a type attribute is very important, right? Are we dealing with test steps? cases at the plan level. The more that you set up, the cleaner your decomposition will be, the better the outputs are going to work, because the output, reports and scripts and things like that can, they'll know what type of test or type of verification activity they're dealing with. So, typing them is a very important step. Let's take a look at typical verification activity attributes, right? So as set up in Genesis directly, we use these basic attributes, right? A name of the verification activity, a number. I do like to point out that the number is for organizational purposes, right? It shows me where I'm at in the hierarchy, because it's a hierarchical number, right? As the number that comes after the dot would be like another level. Really helps to clue me in as to what I'm looking at, what level it is, once you get used to using that that number attribute. I have a detailed description attribute, right? And for the higher level verification activities like test campaigns and test procedures, I'm going to write up a pretty detailed description of what I need there, right? So I'm going to use that description. Then, of course, I have my type that we discussed, right? Step, case, plan, campaign, whatever enumerated values you need for your organization. Status is the test activity or verification activity, sorry. Passed, is it blocked? Is it, on hold, right? We can set that. If you have a responsible party, you can set that as a value here as well. There are other ways to set that. You could do it by relationship as well. Very much depends on just what you need. Then we get into really kind of the important ones for being at the lower level, being at a test step level, right? Preconditions. What are the preconditions the system needs to be in before this test can be done? Does it need to be in a certain state? Do I need certain equipment, right? I can list all that. Post conditions. When I do the test, what's the state of the system going to be in when I'm done? I want to define that. Any special comments, of course, we give you a field for that. And then probably the most important one, the expected result. What do I expect the results from this test to be? I also have an actual result field. Now, an interesting thing about the actual result is I will typically make that a versioned attribute. In that case, that means Genesis is going to track every change I make to that field, right? So if I run this test once and I write down the actual results and then I go and do it again, right, then the older results will just get pushed into that versioning. And so I can always get back and see that history of the test. But Genesis is always going to show me in this attribute the latest results, okay? There are some other ways to handle that. If you're doing a lot of automated testing or things like that, there are some different ways we can handle that as well, but this is more of the typical flow. Some of the other basic attributes too would be dates, right? What's my start date? What's my actual start date? Planned end date, right? These are things I can use to help sync up with some of the planning tools, Microsoft Project, things like that. So I do like to point these out as just kind of basic attributes. Of course, you can add, you can modify them, you can, add additional verification attributes that you need for your process. And that is one of the absolutely beautiful things about Genesis is the control of this language, right? All of those enumerated values are set up by the administrator and only changeable by an administrator or somebody who has that level of permission. So they can set up all those values for the entire user base to use, right? So I can't just have a user going in there and setting, creating some random attribute or some random value, right? I'm controlling that language, which allows me to produce outputs later on, right? Because I can look for certain things. I have common data language and data model to work with. Talk about activity traceability a little bit, right? So I keep showing these design language charts here, right? What the class is and what the relationships are. So verification activities really are kind of that focal point, right? They're that center. Even though in this diagram they're kind of showed off to the right, underneath verification requirement, they really are where you're putting together all your verification flows and everything. Right? They execute the verification requirements so that they can gather data, right? Right, and again, they perform to gather that data. Okay, they accomplish verification events, right? So this allows me to, put in there individual test events, right? Like this is flight test A and this is flight test B, right? And flight test A is going to cover all of these verification requirements. Flight test B is going to be focused on some other aspect, right? But those are actual events that can have dates and that you can plan around. Okay. They can employ test configurations, right? So, typically, right, we have behaviors that are being performed by components, right? Well, verification activities employ test configurations, and they can employ other components that aren't necessarily part of your system. They can employ, test equipment, data acquisition units, right? Oscilloscopes, whole aircraft, whatever you need, you can put that in the model as well and tie them to that. So you can have that traceability tree there. Oops. All right. All right. Let's move on. So this next section is on, using your model to, guide your verification plan creation a bit. Okay. Oh, and that brings us to our third poll question. So I'll turn it over to Steve again.
All right. Does your organization have a detailed behavior model you can use to guide your verification activities? Clicking along there, pretty good.
I love seeing them updating in real time.
Yeah, it's a neat feature of the poll questions in Zoom.
Yeah, that we can see.
All right. Just about, we're 67, 68%, so we'll give it another 10 or 15 seconds here.
There's still a few votes trickling in.
All right, I think that's a pretty good response. We can end the poll.
Okay.
What do you think?
I think I'm not surprised. There's a lot of no's in that. I'm very happy that there's a small section, 18% or so that said, yes, you do have a behavior model. That's awesome. Going forward, I think you're going to see why having a behavior model really does help you with tests. But I'm not terribly surprised. My past experience has been the same. Unfortunately, behavior modeling is this place where, as systems engineers, we can have the most effect on our products and projects. But at the same time, it's one of the areas that's just mostly not done, or not done well, at least in my experience. So I hope we'll see a change in that. I hope we can start, using those behavior models more and start seeing some of the benefit. So great. Thank you.
All right.
All right. All right. So just as kind of a background here, as to bring that home a little bit, is, what does a model provide, right? So I'm talking about, a model-based systems engineering model, right? A good descriptive architecture model, right? It really does provide a communication medium between the systems engineer, the test engineer, and, to be honest, all the other disciplines, right? It allows me, a good model should allow me to communicate with them, to put it into a view or into language that they understand, right? So these models should be simple enough, to be translatable into artifacts that other organizations can understand. I mean, I'm not going to want to go in front of a team of electrical engineers and show them a detailed, software sequence diagram or something like that. I want to translate it into something they understand, even if that's just pulling the data out of the model and putting it into an Excel spreadsheet that they can understand. That's fine. A good model should be readily translatable like that, right? Models allow visualization, right, of all of the complex relations and elements of the system. So often, this traditional way of producing something, right? Microsoft Excel, writing the Word document, it's great and it helps, but it ignores those relationships. It doesn't help you visualize those relationships and where things are missing. Okay. So again, models serve as that coordination and communication point. They help you to discover inconsistencies, right? And to visualize the flow of that information. Our systems are getting so complex. Managing this through Excel is just going, no matter how great an engineer you are, none of us, as much as we'd like to be, are super people. We can't track every little bit, and Excel and Word does not help us with that anymore, right? Things will get missed. So really, we can use this to communicate that expected and desired behavior of the system. So how does that help us for test and verification activity planning, right? It can really, form that roadmap for verification activity planning, right? Our behavior model can really suggest what we need to test, right? So often testers are just told to go test the system, right? They may have a couple description documents. They may have, if they're lucky, maybe some spreadsheets with some behaviors and functions in them. And then they have to kind of figure it all out. Well, is that really the most effective way to do this? No. I mean, we do want them to look at it as a black box, right? So that they can see things that maybe we missed because we were too close to it as systems engineers, right? That's all good. But once they've done that, we want to open it up. We want to give them a good behavior model. We want to give them this architecture model so that they can really start seeing how the decisions were made that resulted in the requirements that they're testing, right? And it becomes a roadmap for the test. So in this chart here, I have an activity diagram, right? And this is, again, I know it's small and hard to see, but I'll zoom it in on a section in the next chart. I just want to kind of show an overview of a behavior for our drone, right? And this is like an initialization and then start up, and then it goes into, behaviors that our drone internally is doing. When I look at this model as a verification, activity author or, verification planner, or test planner, however you want to say it, I can see that right away. Okay, I see right here, there's two functions that have to do with initialization. Great, those are actually requirements. I can trace those requirements to verification requirements, so I can see exactly what I need to do to test it, and then I can group them into something like a drone initialization testing, right? That can become my test procedure. The model, just looking at these behaviors, clearly can show me where the most logical places to group and to build my tests, right, and which verification requirements to cover, all right here in the model. This is why having this behavior model up front is so powerful. It makes doing this test planning easy. I've had a few times in my career where I've had a model like this, and then I went to verification planning, and the test plans wrote themselves. Everybody else that didn't have a model was struggling and trying to figure out how the system worked, making mistakes, taking a lot of time, taking up a lot of resources, right, in the labs and in the systems to figure this out, right? And I just walked right on. Everything ran very smoothly with as minimal amounts of issues because I had a behavior model that was used to write the requirements to guide me in my testing. Absolutely powerful. Take a little bit closer look at that. So here's a zoom in on that activity diagram. And again, you're not seeing all the context, but right, we have two functions: initialize the drone, confirm the link request. We can see there's some loops in there, and there's some loop backs. There's some different options. We can see some inputs and outputs here, right? That when I initialize my drone, it's getting a switch position, and then it emits a chime, right? And then after we go through the link request, I get a link request, I output a link confirmation, right? So I can see. And then from this point on, if we had the model open, we would see that we start getting into the drone running on its own. So we're really not doing initialization testing, right? At that point, we'd move on to doing, remote control input testing and in-flight positioning testing, things like that of utilizing the drone. But the model suggested the fact that we have to do initialization testing. So I can break that out into test steps, like detailed test steps, and I can use the model to inform that, right? I know right now that, I know my drone's going to emit a chime when it powers on. So I want to make part of my test to either hear that chime comes on or that chime doesn't come on in certain conditions, right? I can use that model to inform this test flow. Okay. It becomes very obvious when you have this kind of model. All right. So as promised, we're going to talk a little bit about identifying gaps in your verification activities. So really, how do you do this? How do you identify these gaps? I usually think of it as in three major ways to do this, right? Simulation, simulating my verification plans as I've designed them, right? We'll get into the details in a couple of these other charts. Traceability, right? Reports, tables, matrices of information, looking for missing relationships, very key. And then finally, visualizing the verification plans through the model, right? Using that model as that communication medium to discuss it and get consensus with my test team and all the stakeholders. Let's talk about simulation a little bit. So in Genesis, I have the ability to execute this verification activity model, right? I can turn it on. It's a simulation. It's a flow, right? It will execute in time, and I can execute the verification model, right? What does this help me do? Well, one thing it can do is to hold on. Yeah, okay. One thing it can help me do is see conflicts and resources, right? Sorry, you should be seeing my screen. Okay, sorry, I was getting a message. Yeah, so I should be able to see conflicts when things are using the same resource, right? And I have to wait for a test because this test is using this resource, right? Things like that I can see in the flow pretty easily. I can model uncertainty in the durations, right? Here in the tool, I can apply a distribution to the duration, right? I can say, yeah, this test takes about 6 hours, give or take a couple hours on either end, right? We can put that in there and model that uncertainty, right? Then we can plug it into the model. We can run the simulation, um, you know, 1,000 iterations, right? A Monte Carlo model, and then look at the results of each iteration and find the average iterations. So that's going to result in a much more accurate verification execution time, right? Another benefit, we can discover errors in that verification activity logic, right? We can see where, well, this verification activity had to output something, right? And that triggered some other verification activity to execute. Well, if that previous activity never executed or was blocked, then this one is blocked, right? So then the whole model doesn't execute and stops, right? So we can look for that kind of logic errors, or when certain things don't complete that have to be completed in parallel, and that blocks the model, right? Those things can be pointed out really easily here, of course. Then we can build this nice timeline view like I'm showing here. We can export that to something like Microsoft Project, and that can be the foundation for a plan, for a real test plan. Of course, this test plan is now tied back to the model, right? It's tied back to some uncertainty, to all this logic that's been verified in the tool to be correct. It's tied, all of those events are tied back throughout the model to the systems architecture pieces as well, to which functions they're verifying, which components, right? Requirements, all of that traceability. So you can think about it, any one thing changes, right? This one component changes. Well, now we can see all the way down to the test steps that it affects and what the uncertainty of that duration of that test step was. And can we maybe make that less uncertain if we put in a more reliable component or something? All those sort of things we can do right here with this level of traceability in a model-based verification approach. All right, traceability reports, tables, right? Again, looking for missing relationships in the model. In Genesis 2023 and in the Service Pack 2, we've introduced having table views directly in Genesis. Before, you had to use Microsoft Excel. Now you can do that here, and you can really build out, tables of data that are very useful for seeing missing things. And of course, the matrix view, very useful. I can put my verification requirements on one column, my verification activities in another, and instantly see an orphan, right? Instantly see there's no error, no arrow connecting, these two. Why is that the case? Right. So again, tracing every verification activity to a verification requirement, right? Looking for plans or steps that may not be needed, right? So if I have a verification activity and it's not linking back to any sort of verification requirement, why do I need it? Do I really need it? Is it a setup step? Okay, but then I need to make that conscious decision that that's why I'm doing that, right? Orphan verification requirements. Do I have, the other way? Do I have a verification requirement that doesn't have a verification activity? I missed something, right? Now I'm actually not gathering evidence for something I need to. That's an important thing to miss.
Right? All right.
Getting low on time?
Yeah, we're right about at their time limit here if we want to get some question and answers in. So
let me go ahead and finish up then with a few charts, and then we'll switch to question and answer. So I'm going to move a little faster here, but one thing I want to point out is take an existing test plan, take your test plan that you've done through Microsoft Office, products, right? Word and Excel, model it, look for orphans. You're going to find test steps that weren't traceable. You're going to find verification requirements that were incorrect. Real quick, model visualizations, right? Use the model to share that flow of activities to the team, however that makes sense, through HTML outputs, through direct images, through Excel spreadsheets, right? Get that buy-in early, right? Build consensus in the model. Get all stakeholders involved. In the past, I've had I brought the model up in front of huge organizations and stepped through it. And yes, it was a little painful in the beginning for everybody to get on board with the terminology, but once they did, we produced invaluable, products and correct flows. All right, so use whatever medium works best for your organization. We are running a little on time, so generally I was going to say that verification artifacts, right, managing results, these are outputs from the tool, right? Test plans can be generated from this tool that are in regular document format, right? Again, that follows the decomposition of verification activities. This is just kind of the roadmap for how it would read down that decomposition. Excel, right? Word documents are great for formal documents, but they are very hard to put a lot of information in, right? The page size is just very restrictive. So sometimes being able to build a larger table with more attributes and more information can be useful, right? Excel or a custom table output can do that and help you. Again, it's getting the data that you put into the model out there for review. And then, of course, connecting to other tools, the digital thread, right? Everybody wants that now, and they can see why, right? We still need documents for CM, right? We still have to do that. But at the same time, being able to connect data directly to these other tools and have them use this is just so much more powerful, right? So Genesis already connects to several of the digital thread tools on the market. If need be, you can use the API to create a direct interface with whatever tool that's in your tool chain that you need, right? And create those custom connections. Okay, so again, one popular one, automated test tools, right? Sending the procedures, receiving to those tools, right? They can execute and then send back results to Genesis if need be, right? Very common use case. So my 3 takeaways, and then we'll move into questions. Don't overlook writing verification requirements, right? VRs are a fantastic way to ensure the quality of your requirements. Model-based verification planning creates better results by increasing the rigor, increasing traceability, and even reviewability of your verification procedures. Right? Use existing behavior models to inform your verification activities, and then use the models of your verification activities to communicate that verification flow. All right. I hope that was interesting, and I guess we'll go ahead and open it up for questions.
All right. We've got a number of questions here, and they keep coming in. So I've tagged a bunch of them to try to answer here live at the moment. Let me start with one that came in early. How often, in your experience, can verification requirements be reused?
Generally, a verification requirement should be tailored pretty directly to its requirement, right? So as part of stating the objective, I usually kind of restate the requirement. So the reuse aspect of a verification requirement may not be as high as I would normally think. It very much depends. If I'm reusing that requirement, then the verification statement can go with it. But typically, I write them on a one-to-one basis. It is effort, but it's that effort of like proofreading, right? It's worth it to spend the effort to do that uniquely for each requirement.
Okay, thanks for that.
Yeah.
Next question comes in and says, sometimes process product requirements that are cascaded down to the detailed design level need to be verified based on the detailed or the design related artifacts, CAD, assembly, etc. Is reviewing considered a success criteria? Is reviewing the detailed design artifact considered as a verification method?
Sure, it sounds to me like that's inspection. Right? If I'm going and examining or inspecting it, measuring it, making sure something fits inside a volume or, something like that, that's very much inspection. So even if you are just verifying it based on the digital representation, as long as that is part of the, configuration managed flow of your product, that should be acceptable. And of course, in the end, it's whatever your QA guidance is, quality assurance, or your customers, accept. If they accept that, then that should work fine. Yeah.
Okay. Yep. I would treat it the same way. It's a verification activity, even as part of the engineering process, right?
Mm-hmm.
Verifying your artifacts can be considered part of that verification effort.
Mm-hmm.
Yeah, very much. Next question. And I'm going to do a little tweak to this question. The question says, does verification activity include a percent retest? And I guess I would turn that around and say, can you take your verification behavior or simulation and include some percentage of retest for planning purposes?
I would say sure. Uh, yeah, if you're very interested in tracking that kind of retest metric, right, you could actually add an attribute that would test, or track how many times. You could, in Genesis, I'm just thinking how I'd even approach that. I could write a little script that would look at the results uh, versioned attribute, right? See how many times it was loaded with results. So it would show how many times it was retested. Yeah, there's a bunch of different ways to handle that. And if you really need that metric, then sure, that's something that you would look to add into the schema maybe, or to build some kind of custom script to track.
Okay. Yeah, I'm same opinion is that you can, if you can think of it, you can probably build it into the
Yep.
activities. Um, Next question. Do you have a link to use Maple MBSE to assist in behavior modeling?
That's a great question. And that is a feature at the moment. I would say no. Um, we are working on that integration now, so that will be coming out in the Genesis 2024 product release. So we'll have some guidance there in integrating Maple.
Okay. I'm going to take one more, and as we're at the end here, we will answer any of the questions. You will get an email with response to any of the questions. But this last one, um, is industry normally driven by time pressure to deliver projects? Did we measure the time cost of doing a good verification plan versus the current practice of moving faster? The big problem we see is that organizationally, leaderships do not understand those concepts.
That is such a great question. And that's why, when you can do an analysis like this, you can use an MBSE approach to show them how much time they can save. That's when you get noticed. That's when the management really starts taking note of these things. I was lucky enough to be on a project where we got to do that, and the savings were just insane. Some of the things that program manager said were not were just, it blew his mind as to how much time we could save by actually, doing a good verification planning process, right? And really spending the time up front to do that. It just was worth it. So that is a great question. The best way to do that is to show them improvements, right, in the parts of the program that you can do this. Uh, it's kind of generally been my approach to handling that. So great question. Uh,
All
every
right.
organization is going to be slightly different.
Yep. Well, thank you, everyone. And thanks to Andy for his expertise in presenting this information to us. Um, there are Andy, Zukin, and Vitek are all available in LinkedIn. So you can access any of the information and even us as individuals to be able to get more information. Um, we hope that you found the webinar interesting and helpful. The links to the Zukin webinar series will be made available, and the recording will be available to participants. Um, Thanks again. Have a great day.
Thank you.